Okay, let's discuss section 1.7, the problem solving. Interest, mixture, uniform motion, constant rate job applications. Okay, so basically we want to apply what we just learned to the real problem. First, we have a word problem. It has no x, no y, no variable. And then you're going to name some variable by x, by y, by s, by t, by whatever your favorite letter. And then you set up the relation among those variables. And this process is called the mathematical modeling. So this section is the first section to discuss the simple exercise, simple word problems. Okay, so first, let's see, translate verbal description into mathematical expressions. Translate verbal descriptions into mathematical expressions. Okay, so first, let's see. So, A, for uniform motion, uniform. What is uniform motion? Uniform motion means it has a constant speed. Like for example, when you drive a car, you say, okay, I will drive a car with a speed always like 45 miles per hour. So that is a uniform motion. It's a constant speed of an object. Okay, so this uniform speed is related to other quantities. For example, if you know the time, like you drive 2 hours, 3 hours, 4 hours, then you have certain total distance. Then the total distance is equal to the speed times time, right? In other way, the speed is the distance over the time, right? So the constant speed of an object equals the distance traveled divided by the time required. Okay, so that's the relation between the constant speed, total distance, and the required time. And when you have this, then you are going to name them. So r, speed, d, distance, t, time. Okay, when you have rdt, then equal is equal. So you get r is equal to d over t, right? R is d over t. So that's the translation from the verbal description. This is verbal description. This is a mathematical expression. You can translate those relation. Whenever you have equal, it represents certain relation among the variables. You can also translate the operation. So let x denote a number. X is a number. The x, the number 5 times as large as x, 5 times as large of x is 5x, 5 times large. So it's a 5 times x. The number 3 less than x is x minus 3. You see, this is more clear than the long sentence. This is also better than the sentence, right? Description. So 3 less than x, so x minus 3. If the number that exceeds x by 4 exceed x by 4, it's bigger than, greater than, so x plus 4. Okay, then the number that 1 added to x, so the number add number plus x, that gives 5. So number plus x gives 5. Then this is 5 minus x. So see, so this long verbal description is equivalent to this mathematical expression. So that number added to x gives 5. Number add x is 5, so the number is 5 minus x. Right? So this is how we translate those operations to the mathematical expression. All right? Okay, so in the textbook, the author summarized several important steps for solving applied problems. First, let's briefly go through those steps, and then we're going to apply those steps for the concrete problem. Steps for solving applied problems. Those steps are on page 135, so you can find them. So first, let's go through them one by one. Step 1, read the problem carefully. Here it says perhaps 2 or 3 times. Just read the problem. Read the problems. Pay particular attention to the questions being asked in order to identify what you are looking for. So basically, read the problem, find what you are looking for, what you want to compute, what you are looking for. You want to solve for the distance, or you want to solve for the speed, or you want to solve for the time. Okay? So if you can, you're going to determine the realistic possibility for the answers. Well, if you can do that, you will skip the rest of the steps. So basically, you cannot do it. You cannot find the realistic possibilities for the answers. You just figure out what you're trying to compute. Okay? So step 2, assign a letter, assign variable to represent. Assign variable to what you are looking for. To represent what you're looking for. To represent what you look for. Okay. And if necessary, if you okay, represent any remaining unknown quantities in terms of this variable. Okay, so basically you represent what you're trying to find, and then you use this variable to represent any other, to express other quantities, as many as you can. Okay, so that's the second one. And step 3, this is about unknown. All the things are unknown. What you're looking for, it is also unknown. And step 3, make a list of all known facts. So basically, you're going to connect an unknown quantities to the known quantities. Okay, and set up the equation. Right? So step 4, solve equation. Whenever you connect them, basically it means that you build the equation. You solve the equation. Solve the equation, you will get the answer, but remember, here when you solve the equation, you are going to solve it abstractly. So possibly you will have a positive number, negative number, 0, square root, something. But after you get the answer, you have to verify it in this real world problem. In the real world problem, possibly you don't have a negative time, or you don't have a negative length, something. So you have to check the answer. Okay, so this is the summarized 5 steps in the textbook. All right, so we are going to follow those steps. Will not always get 5 steps. Possibly for some problem it's simple. You just have first step, and you combine step 2, step 3. You get the equation, solve equation, check answer. That's it. Okay. Yeah. So you may have some step missing. That's not important. Okay. Now let's see the concrete stuff. Concrete problems. Solve interest problem. What is the interest problem? Interest is the money paid for you for the use paid for the use of your money. Okay, so interest is the money paid for use of money. If you borrow money from the bank, you need to pay interest to them because you use their money. If you put your money in the bank will give you interest because they will use your money to invest and get a profit. So they use your money. So whenever they use money which they don't belong to, they don't own, whenever they use money they don't own, they are going to pay the interest. The second money, they use the money, that money is called the principal. Principal. Okay, and the rate of the interest expresses as expressed as a percentage as a percent, not percentage, as a percent is the amount charged for the use of the principal for a given period of time. For the given period of time. Okay, so basically, for example, if you deposit $100 in the bank, they possibly will say after 1 year you will get very low, like 50 cents, possibly. I don't know the rate so far. Okay, so that is the rate of the interest. Of course, if you have $1,000, it will be $5, and $10,000 will be $50. So it's proportional. So interest rate, whenever you see the rate, it's proportional. Okay. Okay. So the simple interest formula. Later we will see that compound interest formula, but so far let's see the simple interest formula. What is a simple interest formula? Okay. Simple interest formula says the following: if a principal of $P is borrowed for a period of T years at a per annum interest rate R. Okay, so if the principal of $P is borrowed for a period of T years at this per annum interest rate R, then expressed as a decimal, the interest I charged is I is equal to P principal times the interest rate. It means you save for 1 year, because here you have T years times T. So this is a so-called simple interest formula. So you have a principal times interest rate times how many years. Okay. And the interest charged according to this formula is called the simple interest. Why it is called a simple interest? Remember that you deposit 100, for example, you deposit $100. If the interest rate is like 1%, then after 1 year, you actually have $101. And this is simple interest rate. It means after 1 year, if we count the second year, you still have this this is total principal. You still have this interest rate is 0.1. You see, the PT, well, I'm okay, sorry. The interest is $1. $1. After 2 years, it becomes $2. $2 means you have the principal is still $100. The rate is 0.01. But the thing is that after 1 year, you do not just have $100. After 1 year, actually have $101 because they should pay you the interest $1. So after 1 year, suppose they need to change the principal from 100 to 101. So it should be like principal is 101, the rate is 101, and this is a 1 year. So the interest should be 101 times 0.01 is 1.01. Well, that's tiny, but it's different. And if you go through this very, very complex idea, this is called compound interest. It's called compounded interest. Here we ignore this the profit by this the first year interest. This is called the simple interest. I don't care about this 1 cent. I just use this basic formula. After 1 year, you get, you see, after the second year, you should get $1 plus this $1.01. You should get $2.01. Okay, you understand what I mean? The first year you have $1. You need to put $1 together with your principal. You get $101. And in the second year, your principal should be $101, and the rate is 0.01, and you deposit for a year. The interest is $1.01, and together with the first year $1, you earn $2.01. If you have such complex idea, this is called compounded interest. But if you just ignore this $1 in the second year's profit, you can see that every year I just use this $100 as interest. Then after 2 years, you should have $2. So the difference is 1 cent. It's not a big deal if you do not have a lot of money. Okay, so that's the difference between the simple and the compounded interest. We will learn this later, but so far, just keep in mind we have this simple interest. Interest is a principal times R times T. Interest I is a principal times the interest rate times the time. Okay. Okay, now let's see the example. That's an idea. Let's see the concrete example. So suppose that Juanita borrows $500 for 6 months. At the simple interest rate of 9% per annum, what is the interest that Juanita will be charged on the loan. How much does Juanita owe after 6 months? Okay, so there are two questions. What is the interest rate? How much does she owe? Okay, so that's two questions. So we know that the interest rate is 9%. That's per year. Here she only borrows for 6 months, so it's a half year. Interest rate is 9%. You're going to write it as a 0.09. Okay, so the interest is the principal times rate times the time. Principal is $500. Rate is 0.09. Time is about the number of years. Here is a half year, 0.5. Okay, so you do this computation, you will get the interest after 6 months is $22.50. So this answers the first question. What is the interest that Juanita will be charged on the loan? She will be charged $22.50. And after 6 months, Juanita should pay back $500 plus interest. So after 6 months, Juanita actually owe $500 plus 22.5. So it's a 522.50. So this is the amount of the money Juanita owes. $522.50. This is the interest charged. She's charged $22.50 interest. Okay. Another second example. Okay, let's stop this video, and we will continue the discussion, the second example, in the next video. Okay, thank you.